So from the last video we talked about doing a question. So let's do a question, which is to check. So this is my symbol for question. I can also write Q, or I will generally write like this if it's a question. So now let's see. Check the correctness. Check the correctness of the following physical relations. So we have three over here. The first one is V square root gamma P by rho. This is not R, this is gamma. And here V is velocity, P is pressure, gamma is a constant, and rho is density. So rho and gamma are the name of these symbols. Okay. In books you will find the symbol of rho as this as well, but this looks like a P, so I'm gonna write it like this, and most teachers also follow this, prefer to write rho as this. So another one, the second question, this is the second part is R divided by 2gm whole square root. So here R is the radius of something, and G is the gravitational constant, big G, and M is the mass, capital M is the mass. Now let's move on to the third question, and which is P is equals to 2me by t whole square root, where capital P is linear momentum, capital E is, so I wrote small e, it's supposed to be capital E, so small m capital E. Capital E is supposed to be energy, and T is supposed to be time, and M is mass. Okay, so before I tell you how to solve this, if you watch my previous video, you might have a good idea on how to solve them. So try to solve them and pause the video and try to solve them. So let's see the question, first, second, and third, and pause the video and try it. I hope you did it. So now let's try to solve it. So the first one that we have is V is equals to gamma P by rho, right? So here dimensional formula of velocity is LT minus 1, because it is displacement over time. Similarly, dimensional formula of P or pressure is ML minus 1 T minus 2, because the formula of pressure, if you remember, is force upon area. Next one is dimensional formula of rho. Dimensional formula of rho is ml cube, because rho is density, which is mass divided by volume. And finally, gamma has no dimension, or gamma is dimensionless. Okay, so now let's move on to the dimension. So now the dimension of LHS is V L T minus 1, pretty simple. And the dimension of RHS is I forgot to write here dimension, because in the left side there is only V. Okay, so now the dimension of square root gamma P by rho, which is the RHS, can be written as the dimension of rho, it's nothing. The dimension of pressure is ml minus 1 T minus 2 divided by the dimension of row, which is m l minus 3, and it is raised to a power of 1/2 because square root means 1/2. Okay, so now if you simplify this, you will get L square t minus 2 to the power 1/2, which means the dimension of RHS is L t minus 1. So look, the dimension of LHS and the dimension of RHS matches. Great job. So now let's write the conclusion. Since dimension of LHS and RHS is equal, the given physical relation is dimensionally correct. It might not be physically correct, but it is dimensionally correct. So the next question that we did was 2, which was v is equals to square root r by 2 big G m. So here let's do it by the same way. The dimensional formula of velocity v is Lt minus 1. Pretty simple. And the dimensional formula of radius is a length, so it will only be L. And now let's do the dimensional formula of m. The dimensional formula of m, which is mass, will be m for mass. And finally, the dimensional formula of g, big G, will be m minus 1 L cube t minus 2. So over here you might see something. How would you find the dimensional formula of G? So when finding the dimensional formula of G, because not everyone remembers it, you can do it by F is equals to Z m1 m2 by r square, because that's a working formula, that's a correct formula. But don't find G from this relation, because this relation may be wrong, dimensionally wrong, which means if you found it by this way, you will get the wrong dimensional formula of G. If you want to find the dimensional formula of G, find it from a formula that actually works. This formula might work, might not work. And in this question, it actually is dimensionally wrong, which means if you found G from this formula, you would get the wrong answer. Because if you found G from this formula, you would be in a very bad situation. Let's say it like that. So when finding the dimensional formula of anything that you might not know or might not have remembered, find it from a formula which is that works. You know that it works. It can be a simple formula, complex formula, but you must remember how it works. So LHS, you just have to find it off V. Always forget to make the brackets. Big problem. And some teachers may not make the brackets. Actually, it will be better if you make the brackets, but if you are learning for entrance or something like that, many teachers will not make the brackets and just write MLT. So they will write it like this. But the correct method, or the method that I would suggest that you use, is putting a bracket over it to understand that it is actually about the dimension. So the dimension of RHS was R2GM. There is a square root over it and a bracket. Not the greatest bracket, but works. Okay, so it will be radius is L. 2, there is no dimension of 2. Oh yeah, I forgot to write, but not necessary. So 2 has no dimension. Similarly, capital G has minus 1 L cube t minus 2, and M has the dimension of M. So that's the dimension. So let's use a shape this time because it will make it cleaner. It's supposed to be brackets, but this brackets will also work. It's supposed to be square brackets though. So it's 1 by 2. So if you solve this, so look here, m minus 1, m1, that will cancel out. Here L cube, so going up it will give you L minus 2, and t minus 2 going up will give you t squared. So dividing all of them by 1/2, you will get TL minus 1. I hope you can do that much. I'm not doing it because I will have to write it over here, which will be a little difficult for me. So now, as you can see, does the dimension match? Nope. They are kind of similar. They kind of look similar. They are of a similar style, but they are not the same. Which means we can write the conclusion as, since dimension of LHS and RHS are not equal, the given physical relation is dimensionally wrong. So if a relation is dimensionally wrong, it means that it is physically wrong as well. Physically meaning the formula does not work in general. If it works dimensionally, it might not work in reality, but if it works, if it's wrong dimensionally, it means that it will not work 100%. That's a guarantee. So let's move on to the last question. Woohoo! So, and I would recommend you to find dimension of anything that we do going forward. So in any other chapter that I teach, there will be some formulas. Of course there will be formulas. Why wouldn't there be any formulas? If there is formulas, try to derive their dimension, which will make it habitual for you. So here, dimensional formula of P, which is pressure, is mLT minus 1. Oh sorry, was it pressure? Oh sorry, it is linear momentum. So that's why the question over here had stated that it is linear momentum, because you get confused. Because when I see P, I think of it as pressure, but it can also be linear momentum because both of them have the same symbol of P. So next one, dimensional formula of M, which is mass, which will be M, and similarly dimensional formula of E, which is energy, will be mL squared T minus 2. This is force into displacement, this is energy upon time, mass is just mass. And finally, dimensional formula of T is time, because T is time. So I'm not gonna write 2 is dimensionless. If you wanna write it. I'm not writing it because I would have to fix it again. I would have to move all of these above. So now, dimension of LHS will be this, since LHS only has linear momentum P. So this will equal to mLT minus 1. So now let's find the dimension of RHS will be 2me by t square root, and let's put a bracket over it because it looks prettier that way. So now the dimension m, 2 does not have a dimension. The energy has a dimension of L squared T minus 2. Finally, time has a dimension of T. So now let's make it prettier. So let's do this. Let's put a divide symbol and let's 1/2 it. Or you can put a square root over all of them as well. But I like to put 1/2 because drawing square roots over big things is pretty hard. So now, if you simplify this, you will get, so think about it, it will be m squared, and t minus 2t will be t minus 3, right? But it's all being half, so we have m squared, which will give us m. So L squared, which will give us L. Pretty good so far. Now let's look at the last one. It will be t minus 3 by 2. It will be t minus 3 by 2. Oh, it does not work. We thought it worked when we saw the first two, but when we saw the last one, we knew that it does not work. So let's write it. Since dimension of LHS and RHS are not equal, the given physical relation is dimensionally wrong. So in the next video, we are going to learn about how to derive a relation between various physical quantities. Bye bye.